All right, hey, I made a nice video explainer on number 6 earlier at school, and then forgot to upload it before I got home, and it's kind of long, and you weren't going to watch it anyways because it was long. So here's the quicker version. Problem 6. So your person standing over here, they're firing their shot at some angle, and it's going to travel over here. Eventually, it comes back down to the same level, okay? Um, and a little bit later on, eventually it gets to the level of the feet of the archer. But the problem with this problem is that the ground is kind of falling away from them there. Okay, they're on the side of an incline. And so the farther you go horizontally, the farther down the ground is vertically. So this is just not fun. You'd have your VX graph, you'd have your VY graph. You get over to a certain point, you can imagine there's some point where those two areas cancel out. That's going to be when it's right here, okay? When it's come back down as much as it went up. Goes a little bit farther down, 1.75 meters down, right? That'd be over here. So I'd add in a little trapezoid that's got an area of 1.75 meters. Then it's going to go even farther yet before it gets down here. And so maybe there's some kind of way of representing this trapezoid, relating it to the extra area on the end of the horizontal. And that's just not fun. So a couple of folks had an idea. So credit to Weiwei and Jacob for thinking about it like this. You know, in this frame, or in sort of the image of the problem, you've got gravity going like this. You got your 9.8 meters per second squared. It's pointing straight down like that. Okay, that's cool. But they wondered about maybe rotating this problem. So basically what we're going to do is everything's going to rotate that way, including our archer over here, so that the ground becomes flat. Okay, so then what's that going to look like? Well, that's going to look a little bit like this. So now the ground is flat because we rotated everything up 15 degrees. Okay, so if this goes 15 degrees this way, now the archer's going to rotate back 15 degrees that way. That's going to rotate their shot. It was fired 20 degrees above the horizontal, but again, everything's rotating 15 degrees. So now it's going to be 35 degrees. Sorry, there's a little bit of work that I'm working over here. Now it's going to be 35 degrees above this new horizontal. Okay, so far so good. For me, this is 50 meters per second, 35 degrees. I can break it down into components, figure out how much of it is X, how much of it is Y. This new X, this new Y, so we'd call this VY prime, and then this down here would be called VX prime for my new axes, which are parallel to this hill. That's X prime, and then perpendicular, or fancy kids might say normal to the hill, which would be Y prime. Okay, so that's all fine and well, but the thing that makes this kind of not so great is that the acceleration, which was pointing straight down in the original frame, now because we've rotated everything 15 degrees, it's rotated 15 degrees as well. Okay, so now this acceleration is 15 degrees from vertical. So some of it, quite a bit of it, is still vertical. So I'm going to call that AY prime. That's 9.47 meters per second squared for me. But now this is where it gets funky. Now there's a horizontal component of acceleration, AX prime, 2.54 meters per second squared. So now instead of having one problem that's CVPM and one problem that's CAPM, both the horizontal and the vertical are going to have some acceleration happening. Okay, so here's where I resolved the velocity into the X prime and Y prime components. One of the other things you're going to have to do to figure out how high they're firing it off of the new horizontal is take the archer's height, because again they're rotating 15 degrees, figure out what that is relative to Y prime and X prime. You'll see why later. You'll figure it out. You're sharp kids. So then what's really funky is for my graphs, so I take these velocities, and the VY graph looks pretty straightforward. You know, it starts at 28.68. This is down sloping. Part of why it's downsloping is this Vy prime is pointing up, and this Ay prime, the acceleration, is down. They're opposite. This thing's going to be, well, it's going to be slowing down here initially because they have opposite signs. That works just like normal. The difference is that this acceleration isn't negative 9.8. It is negative 9.47 meters per second squared. And then normally I'd be drawing my Vx graph like that, constant velocity, but I don't have constant velocity anymore because now I have a component of acceleration which is pointing the same way as my horizontal velocity. So I start out with an initial horizontal velocity of 40.96, but then I'm going to have this acceleration. So not only do I have my rectangle, but I'm also going to have this triangle on top of it. Okay. Oops. Pretending I don't know that right now. I can come down and figure that out on this graph. Okay. Because I've established that the shot is going to be fired for me 1.69 meters above the ground. So that means from where it's launched to where it lands, it's going to have to fall by that much. It's going to have to fall. So I'm saying here that I know my delta y is negative 1.69. That means that that's how much more negative this triangle down here is compared to this triangle. If I add those two areas together, get negative 1.69. Okay. And you can see I already know that about this triangle, and I know the slope. I can figure some stuff out. Okay. And then once I get a time, I can come up here, and I know this value right here. Boop, boop, boop. So I can figure out the area of the rectangle, area of the triangle. And what do you know? That's how far it's moved from the shot in this, how far it's moved from the shot over here, how far it's moved in this new x prime direction. That is not the answer to the problem. The answer to the problem has to do with relative to the feet. Where does this thing land along that incline? So you got to do a little bit of thinking. Keep in mind that the shot happens a little bit behind the feet in this frame. So yeah, that's the quicker, slightly dirtier version of trying to nudge you in the right direction. The key, the crucial thing is rotating everything so this surface becomes horizontal, which then the result of that is that your acceleration is now at an angle to everything based on how much you rotate everything. So you have acceleration in two axes instead of just one. Super cool, super fun. Good luck with that.